Okay, so looking at our assignment, or not the assignment, the practice we did yesterday on the notes, we finished example 4 and 5, and then we had these example problems. So you can check these right now, the ones that you presumably have done. We'll talk through these though. On number 1, you make your factor tree. You got a 1 pair of 3, and you got a loner 3, so it should be 3 square root of 3. All right. On number 2, you have 2 pairs of 2, so that multiplies to make 4. On the inside is the loner 3, so 4 square root of 3. Now, number 3, this is where some people get confused. From the very front page, we should know that 36 is a square number. So if you take the square root of a square number, you should get a whole number, okay? Now, if you did the factor tree, that's fine. But if you do the factor tree, you're going to have no loners. Just a pair of 2 and a pair of 3. So if all you have is pairs, just multiply them. 2 times 3 is 6, no square root sign, okay? So the only time you have a square root sign is if you have loners that are left over, okay? Number 4, this one's also unique. On number 4, it gives us a factor tree with 2, 5, and 7 as prime factors. None of those are pairs. So if you have no pairs, then you cannot reduce it. You cannot simplify it. So it's just going to stay the exact same. So if you have no couples to circle, then it stays the same. Square root of 70 is just going to stay square root of 70. Okay, focus please. Number 5. These 5 and 6, these are the ones that can be difficult because people forget the coefficient. So look at number 5. If you do your factor tree, you have 1 pair of 3, okay? This pair of 3 goes out and multiplies with this 2 coefficient. So this 3 times this 2 is 6. On number 5, again, you got a pair of 3. The 2 is already outside. 3 times 2 is 6. The loner 2 and the loner 3 multiply to also make 6 on the inside. And then on number 6, when you make your factor tree, you have a pair of 5 and a coefficient 3. 5 times 3 is 15. The loner 3 goes on the inside. Okay? Questions on that? So those were the practice problems. Now we're going to move into the next part. So go ahead and flip it over. We're going to talk about multiplying. Okay? Okay, so how do you multiply radicals? It says it on there, and I will explain it. When you multiply radicals, one must multiply the numbers outside, and then you multiply the numbers inside. So it's very simple. Outside times outside equals inside times inside. Or not equals, but write it next to it, okay? So let's go ahead and do that. What's on the outside of example 1? We got a 2 and a 6, okay? So we take those two numbers and we multiply them. So 2 times 6 is 12, okay? And now we're going to do the inside. So under the square root, we have what? 3 and 2. So square root of 3 times square root of 2 is square root of 6. Was that hard or easy? Okay, should be. Not too hard. However, there might be a last step, and your last step is going to be, if you can reduce it, reduce it. What are the factors of 6? 2 and 3, okay? Are there any pairs? Okay, so we're actually going to leave it as 12 square root of 6, since there's no pairs. Okay? Writing this down on our packet. Do you have a packet? Can you get one off the table? So, on example 2, we're going to do the same thing. So the outside 3 times 4 gives us what? 6 times 2 gives us what? What do we have to do now? Factor tree. 2 times 6, 2 times 3. What do we need to multiply? The circled 2 and the coefficient 12 multiply together to give us what? 24, and then square root with our loaner is 3. Okay? So, I'm going to give you 1 minute to try these two on your own. Believe me, it does not take that long to do these 2 problems. Same idea. So go ahead and get started on that, and I'll come around and help you. So I know number 1 was kind of weird, so let me show you what it's all about here. Again, outside times outside gives us what? 12. Inside times inside is 25. Now we want to reduce if we can. So reduce. We have a factor tree of 5 and 5. What do? Circle our pair, cross one out. Now, we have a 5 pair with no loaners. So, we have a coefficient of 12. And a pair 5. What do we do with those numbers? Multiply, and we get what? 60. And there's no loaner, so there's no square root. 60 is our answer. Okay, we know the square root of 25 is 5. 12 times 5 is 60. Number 2. Now, does everyone see there's a little square, there's no number in front of the square root, so you might want to draw a 1. It's an implied 1. And we're going to multiply outside times outside. 1 times 4 is 4. And then inside times inside, it's going to give me square root of what? 6. Does 6 reduce? Does not. So 4 square root of 6 is our final answer for that. Okay, so multiplying a radical times itself. Every radical multiplied by itself is equal to the inside number. Okay, so this is going to be not too hard. So check it out. Square root of 2 times square root of 2. So we know that we multiply and we get square root of 4. What is the square root of 4? 2. Okay, so here's the idea. Square root of 2 times square root of 2 is just 2. Okay, a square root times itself removes the square root sign. So what do you think square root of 12 times square root of 12 is? Just 12. Okay, you could have thought, well, it gives me square root of 144. True, but guess what that is? 12. Okay, so I don't want you to multiply them and then make a factor tree. Here's the shortcut. Square root times itself removes the square root. Okay? So what's number 3 going to be? Square root of 3 times square root of 3 is just 3. And then number 4, Square root of 37 times square root of 37 is just 37. Okay? No big deal. So you don't have to write a step between it. We know that from now on. Okay? So far so good. Okay, next page. Dividing. Now dividing radicals is like multiplying radicals. Okay? Outside, outside, inside, inside. Okay? So let's do this. Dividing radicals, you must divide the numbers outside and divide the numbers inside. So let's do that. What's on the outside for example 5? 4 over 2. What's 4 divided by 2? 2. Okay? Now your square roots. Square root of 15 divided by square root of 3. What's 15 divided by 3? 5. So it would be square root 5. The only thing you might have to do is reduce the radical, but 5 is prime, so there's nothing to reduce, right? Okay, next example. 6 over 2 is what? 3. 10 over 5 is 2, so square root of 2. Easy, hard? All right. So look at number 5. On the bottom, what number is implied here? On the bottom there, so it's like a 1. So 8 over 1 is just the same thing as 8, right? And then square root of 4 over square root of 2 is what? 2. Okay, so 4 over 2, we're dividing, right? And again, 2 is a prime number. It does not reduce that radical. Okay, over here, number 6, 2 over 2 is 1. Now, you don't have to write the 1, because again, it's implied. We have a square root, and then 4 over 2, 2, okay? All right, so that's dividing radicals, right? So, this is the part that I really, really want everyone to pay attention to, because this can be confusing. It doesn't have to be. So, as long as everyone's zoned in, focused, okay? So, again, looking with your eyes, your ears are wide open with nothing blocking them, right? Oh, got it, okay. So, here we go, rationalizing a denominator. In math, there are a few things that are like, not good. Miss Marrero says it's like cussing. Now, it's not really cussing. But, here's the deal. You cannot have a square root on the bottom of a fraction.
Because if you see it, you go, oh, no.
It's offensive. Yes. So here's the deal. 2 divided by square root of 3. I want you from now on to think square root of 3 on the bottom. Can't do it. So here's how we get rid of the square root sign. Okay? To get rid of a square root, remember from what we literally just did down here, to get rid of a square root, you multiply by the exact same square root, and it goes away. So, here's what I'm going to... No, don't do that. Here's what I'm going to do. All right? I'm going to kind of get rid of this equal sign for a second, okay? What I'm going to do is, on the bottom, to get rid of a square root of 3, I'm going to put times square root of 3. All right? Now, that's the bottom of the fraction. If I do it on the bottom of the fraction, I have to do it on the top of the fraction. So I'm going to put times square root of 3. All right? And now I'm going to do the math horizontally. So this is not a trick question. 2 times square root of 3. What is 2 times square root of 3? Okay, good. So a number by itself and a square root just go next to each other. That's it. So 2 times square root of 3 is 2 square root of 3 on top. It's okay to have a square root on the top. But on the bottom, what happens? So square root of 3 times square root of 3 is regular 3. If you wrote square root of 9, that'd be okay, but you need to reduce that to 3, right? Now our fraction has nothing on the no square roots on the bottom, right? The only step you might have to do is if you can reduce that fraction, you want to reduce it, okay? So let's try some more practice. Does it make sense? You want to try one of these? Here, help me do number 7, and then I'll let you go. 7. How do I get rid of that square root of 2 on the bottom? Okay. Well, I'll help you out. So if I want to get rid of square root of 2, I'm going to do times the exact same thing. So times square root of, you want to help me do this then? All right, so what do I multiply the bottom by? Square root of 2. Do I do it just on the bottom? Okay, so on the top, 8 times square root of 2 is what? 8 square root 2. And on the bottom, square root of 2 times square root of 2 is what? Now, are we done? You want to reduce it if you can. What's 8 divided by 2? 4. Dividing. It's okay. So 4 square root of 2. Okay? Okay. Take one. All right, so next one. To get rid of that square root of 3, what do I do? Times on the bottom and, okay, 9 times square root of 3. And on the bottom, no square root. That's why we did this, to get rid of the square root. So now it's just, what goes on the bottom? Well, so check it out. When you do a square root times itself, the square root goes away. So square root of 3 times square root of 3 is just 3, right? Can we reduce this? 9 divided by 3 is, so we get 3 square root of 3. Okay, who does not 100% get this? Totally fine. Well, I want to explain it like to you. Everyone understands this? Okay, so help me do this next one. What do I need to do? Okay, so first we start off with the idea we can't have a square root on the bottom, right? So I need to multiply by what? Square root of 2. Okay, so times square root of 2 times square root of 2. Okay, so that's always your first step, right? Now you do the math. So what's 7 times square root of 2? Hold on. So if you have a number and a square root, just put them next to each other. Okay, so 7 square root of 2. On the bottom, what's it going to be? Just regular 2. Very good. Can we reduce 7 over 2? That's it. Yeah, it's not reducible. Okay. Make sense? Who wants a clarification? We can do the last one together. Mr. OKC, you know how to do this? Sure? So explain to me the last one. What do I multiply by? Good. All right. On top and bottom. All right. On top, what do I get? 8 times square root of 3? What do I get? Eight square root of 3. And on the bottom, what do I get? And then do I reduce it? Hey, that's good. All right. Now, that can be tough for some people, but we all get it. And if not, you got to just be honest, and we can teach it to you again. Okay, so that might be the hardest part. So if that's the hardest part, and you get it, then we're doing all right. Next page is going to not be that hard, promise, okay? So last page of the notes is adding and subtracting, okay? So let's remember how to add and subtract like terms, okay? So look at addition and subtraction of radicals. Let's skip down here to A, 2x plus 3x. How many x? 5x. Easy, right? Letter B, 7x minus 5x. So you just subtract the coefficient. 7 minus 5 is 2x. Right, subtraction. And then letter C, what's the answer to that? Who said 8? All right. It's not 8. 8 nothing. Okay? Here's the deal. We have a 5x and a 3y. Are those like terms? No. If they're not like terms, you can't combine them because you can only combine like terms, right? So it actually stays the same. Okay? No like terms. No combo. So again, you can only combine if you have the same terms. Why did I just tell you all this stuff? That's old news. Because square roots are the same idea as a variable. You can only add the same square roots together. All right, is everyone still looking up here? All right, so look at add 2 square root of 3 plus 5 square root of 3. So add the coefficients, 2 plus 5, what do we get? 7 square root of the coefficient, the square root sign and the number under it stay the exact same. Just like the variables, square roots is combining like terms, the coefficient out front. Okay. Now the second one, 4 square root of 3 plus, this should be a implied 1 square root of 3. Add those up. How many square root of 3 is that? 5 square root of 3. Okay. So if there's no square root sign, if there's no number in front, it's a 1. So we had a 4 square root of 3 plus a 1 square root of 3. We get a 5 square root of 3. All right, and let's do subtraction. Right. So 5 minus 3 is what? 2 square root of what? 7. Don't mess with the number under the square root sign when you're adding and subtracting. It stays the same. Over here, subtraction, 2 square root of 3 minus 1 square root of 3 is what? 1 square root of 3, or just square root of 3. Okay. If you write the 1, that's fine. Okay, so let's try these. Dang it. All right, real quick, shout it out. Number 1, what is it? 6 square root of 3. Number 2, 4 square root of 5. Very good. Number 3, 1 here, so yeah, 3 minus 1. 2 square root of 2. All right, number 4, as fast as you can. All right, so remember, you can only add like terms. This is a square root of 7. This is a square root of 5. Those are not like terms. So let me remind you, no like terms, no combo. All right, so do not mess with it. Rewrite it. Okay. Number 5. Are there like terms here? There are 2 like terms and 1 unlike term. So the ones that are like, you can combine. So let's do that. 2 square root of 3 minus 3 square root of 3. 2 minus 3 is what? Negative 1 square root of what? 3. And this leftover stuff, you just write next to it. Minus square root of 5. Another way you could see it written is negative square root of 3 minus square root of 5. Whether you write the 1 or not. Okay. Number 6, what's the answer? Square root of 2, 1 square root of 2. Now 7, if you have 3 terms that are the same, that's okay. Combine like terms. 3 plus 4 is 7. minus 8, negative 1, square root of 2. What about 8? What is it? 5 square root of 5, easy. Now, these last two, don't get tricked. Y'all ready to not get tricked? So, can I add square root of 2 plus square root of 18? The way it is written, or the way it is on the paper, no, but what do you notice about the square root of 18? We can reduce it. So let's reduce it and then see if we can add it together. So, square root of 18, what are the factors? 2 times 9, 9 is 3 times 3. Do I have any pairs? Pair of 3, goodbye. How would I rewrite that? Okay, the circle stuff goes out, 3, square root, and the inside is 2. So, I'm going to bring this down. So, square root of 2 plus 3 square root of 2. Now can I add them? Yep. I got a 1 square root of 2 plus a 3 square root of 2. That gives me 4 square root of 2. Sometimes it doesn't seem like you can add them or subtract them until you reduce it. So let's try 10. Can I reduce anything there? 27 is 3 times 9. 9 is 3 times 3. How would I rewrite that? Okay, 3 square root of 3 minus square root of 3, right? What is 3 square root of 3 minus square root of 3? 2 square root of 3. Because that was a minus 1 right there, right? And that's it. Okay? So, when it comes to square roots, I've covered everything you need to know. Reducing it, multiplying it, dividing it, rationalizing the denominator, adding, subtracting. It's a lot of stuff. So there might be a lot of rules to it, but you have this whole packet to help you, and we're going to do this assignment. Let me get that to you now.